Hello, I'm Mr. Howard. This is part 2 of your Unit 7 pre-calculus review covering quadratics. So we'll start with problem 4 here. It says sketch the parabola y equals 3 times the quantity x minus 1 times the quantity x minus 4, labeling the roots, vertex, and axis of symmetry. Okay, so looking at this form, it's a root form. So root form gives us the roots right away. So the roots are going to be the opposite of this sign and the opposite of this sign. So they are 1 and 4. Okay, so those are the roots. Vertex is pretty simple. Vertex x-coordinate is halfway in between these two roots. So but due to the symmetry of a parabola, the x-coordinate of the vertex is halfway in between the two roots. So we can go ahead and start our sketch over here. Let's do that. So we have 1 and 4. So I'm going to label that there. We're opening upwards, so we have 1 and 4. So our axis of symmetry and the x-coordinate of our vertex is going to be halfway in between. So these are 3 apart, so it's 1.5 from either root. So that will be 1.5 from 1 would be 2.5. So x equals 2.5 or 5 over 2, right? So x equals 5 over 2 is the axis of symmetry. 5. Let's do it this way. X equals 5 over 2 or 2.5, however you want to list it. So vertex is 5 over 2 comma something. So we have to find that something by plugging in a 2.5 here. So axis of symmetry we already found, but we need the y-coordinate of our vertex. So that's going to be 3 times, just subbing in a 2.5 or 5 over 2 here for every x. So 2.5 minus 1, 2.5 minus 4. Let's just use our calculator quickly. So it would be 3 parentheses. Again, I don't mind if you crunch the numbers in the calculator, but you need to algebraically show me what you're doing here. So 2.5 minus 1 and 2.5 minus 4. Okay, so that's negative 6.75. So we'll put that in a fraction, negative 27 over 4. Alright, so equals negative 27 over 4. Negative 27 over 4. So there's our vertex. And as a decimal, so it's easier to track, negative 6.75. So down here, we'll just put it right here. So that vertex is at 5 over 2, comma, negative 27 over 4. You could list these as decimals. That would be fine. So we have labeled everything that they asked us to label. So we'll just graph this in. We could find the y-intercept, but it didn't ask us to, so we won't spend the time to do that. Okay, definitely not the best sketch, but we did find everything: the roots, the vertex, and the axis of symmetry. Everything that they asked us to find. All right, so let's move on to the next one. All right, here's question 5. Write the equation of a quadratic function that has a minimum point. That's our vertex. Minimum point. If it's a minimum or a maximum point of a parabola, then that's going to be our vertex. So at 5 comma negative 2 and passes through this point. So in this case, we're trying to find the equation. They're giving us stuff and finding the equation as opposed to sketching like we were doing before. So our vertex is 5 comma negative 2. And then it passes through 7, 1. So if we want to write the equation, since we're given the vertex, we need to use vertex form. So vertex form for this one would be y equals some value of a, which we don't know yet. We're going to have to find that. And then we would be x and opposite of this sign, so minus 5, opposite of the x-coordinate of our vertex, all quantity squared, and then we keep this sign of our y-coordinate, so this would be -2 out here. Alright, so now we take this equation and we substitute the 7 in for x right there and the 1 in for y right there. Okay, so let's do that. We'll do that in another color. It's to find our a value. So y, we're subbing in a 1 here. That's this one right here, equals a, which we're trying to find. We're plugging in a 7 in for the x, so that's 7 minus 5 all squared minus 2. So now we have 1 equals a times 7 minus 5 is 2 squared minus 2. So 1 equals 2 squared is 4. So it's 4a. A times 4 is, it's easier to write it 4a minus 2. So we add 2, we get 3 equals 4a, divide by 4, and we get a equals 3/4. So now we can sub that a back in right here and write the full equation, and we're done. So y equals our a value 3/4 times x minus 5 quantity squared minus 2. Okay, so that is it. So let's quickly review. So they gave us the vertex, so we're going to write it in vertex form. Alright, we always have to find this a value. Even though they give us the vertex, we need to find this a value before it's complete because we don't know what the stretch factor is. Okay, they gave us the vertex, but we still didn't know what this a value was. So that's the process. So they do give us another point, so we can sub the x coordinate of the point they give us in for x and the y coordinate they give us in for y. So that's what we did right here. So we had everything plugged in except this one variable right here, the a, and we just solve for that and then rewrite it, substituting the 3/4 that we found in for a, and that was our final answer. Okay, alright, let's move on to the next one. Alright, here we have question 6 of your review. Write the equation of a parabola that has a maximum value of 7. Okay, we need to be careful here. It's just the maximum value. It's not the maximum point. So that means the vertex y coordinate is 7. Okay, we don't know what the x coordinate is yet. They just gave us the maximum value. Okay, it has roots at -4 and 10. Okay, so they give us the roots, so we need to use root form. So let's do that. So that's going to be y equals a, which we're going to have to find. We don't know what the stretch factor is yet, times the quantity x and opposite of these two. Opposite signs with these two. So it's x instead of -4, it's x plus 4 and x minus 10. Remember, we have to use the opposite sign there for those roots. Okay? Alright, so we know that the roots are at 4 and -10. So remember, if we have we're not asked to sketch this, but just to help us find the other part that we need to find, which we need to find the x coordinate of the vertex, right? So we're at we have roots at +10 out here and at -4 right here. So we are 14 apart. 14 apart, right? So to find the x coordinate of our vertex, which is also the axis of symmetry, we need to come halfway between. So if we're separated by 14 here, we do half of that, so we come in 7 from either spot. So if this is 10, this is -4, we come in 7 from 10, or go to the right 7 from -4. So I think it's easier to use this one. So come in 7 from 10. So go this way to the left from 10, 7 spaces. So that's going to put us at +3. So our axis of symmetry is x equals +3, which means the x coordinate of our vertex is 3. So there we have the point 3, 7 as our vertex. So now we can plug in the 3 here and here, and the 7 right there for that y, and solve for this a, and then we're done. Okay, so y, we're going to sub in 7 equals the a that we're looking for times x. We're going to sub in the 3 for x. So if we have 3 plus 4 here, okay, we just subbed in 3 right there. We're going to sub in 3 right here now. So that's 3 minus 10 here. Now just work this out. So 7 equals a times 3 plus 4 is 7 times 3 minus 10 is negative 7. So that's going to be 7 equals 7 times negative 7, negative 49a. So we divide by negative 49 to get a, and that's going to reduce to negative 1 over 7 equals a. Okay? So now we've got everything we need. So we just take this a, plug it in right there, and rewrite it, and we are done, because they just asked us for the equation. They didn't say what form we had to write it in, but we are going to use root form because that's what they gave us. Alright, so that's going to be y equals, for this a value I'm plugging in negative 1/7. That's our stretch factor. So negative 1/7, and then this x plus 4, and this x minus 10. So here is our answer, and we are done. Y equals negative 1/7 times x plus 4 times x minus 10. Alright, done. Let's look at the next one. Alright, number 7 here. It says, describe the transformation in terms of f of the function shown to the right. The original parent function was f of x equals x squared, so it's a parabola. Also describe the transformation in words. Okay, so when it asks us for this f notation, we're just going to apply our rules of transformations. Okay, so we can already tell it's been, the normal parabola would be right in here like this, right? That's a terrible drawing, but that's what it normally looks like. So we know it's already been flipped over, right? So that's going to start with negative f already. Okay, so negative f, and then we can track to get our horizontal and vertical shift. It's been shifted left a certain number and down. Okay, so to find that, we just track where our vertex went. Our vertex started right here at 0, 0, so it went left 1, 2, 3, 4, 5, 6. So we want left 6, so that's in parentheses with x, opposite of the sign. We went left 6. Okay, so that's going to be x plus 6 here. And remember, they're asking in terms of f, so we're writing it like this, just in terms of f. So negative f, the negative flipped us over the x-axis. The x plus 6 moved us left 6. Now from, let's see how far down the vertex moved. 1, 2, 3, 4, so it went down 4, so that's with the sign out away from x. So minus 4 was the down 4. Okay, so that is the in terms of f part right here. Negative f, x plus 6 was the left part. Minus 4 gives us down 4. This negative right here flipped us over. So it's a, in words, reflection over x-axis. That's this part right here. Then it was left 6 and down 4. Okay, so that's the description in words. Reflect over the x-axis, left 6 and down 4. Okay, so that part's done. I'm gonna go ahead and stop this video here, and we'll make part 3, the last 2 problems that are word problems. Okay, all right, so see you in part 3.